In this video, we're going to go over area of trapezoids, kites, rhombi, and then a few others. So we're going to start off with our area of a quadrilateral with perpendicular diagonals. All right, so looking at it, we have area of a quadrilateral with perpendicular diagonals is going to be half the product of the diagonals. So we're going to say 1/2 of diagonal 1 times diagonal 2. What special quadrilaterals have perpendicular diagonals? Well, the first one's going to be a rhombus and a kite. And then lastly, we're going to have our square here. And so the square one does change up a little bit just because the diagonals in a square are congruent. And so we just have 1/2 of our diagonal length squared. All right, then we're moving into our trapezoid, so area of a trapezoid. And so area of a trapezoid is going to be half the sum. So we're going to add the bases and we're going to multiply it by the height. So we've got our area is 1/2 base 1 plus base 2 times your height. Area of a trapezoid is also going to be found by multiplying our median and the height. Okay, so just a reminder, median is found by taking 1/2 of the sum of your bases, so base 1 plus base 2. And so that's why it's the same formula, it's just worded a little bit differently. Then moving into it, our last one that we're going to talk about is going to be the area of an equilateral triangle. Okay, just to clarify, when I go over this formula, it is still just the regular formula for area of a triangle. It's just a specialized one that will work for any equilateral triangle given the side lengths. So we have the area of an equilateral triangle is just going to be 1/4 of the product. So we're going to multiply the side squared and the square root of 3. So once again, our formula is just 1/4 our x squared times root 3, where our x is just going to be the side length of that triangle. Okay, and so just to go over it real quick, where it's coming from. So like I said, here we have our formula is just going to be 1/2. I'm going to start off with, we got our 1/2 of our base times our height. And so what they did was they decided that we wanted our side length to be x, like they mentioned. And if you remember, when we have an equilateral triangle, we do have a 30, 60, 90 triangle inside of it. Okay, and so since this is our 2s, right, we would divide that by 2 to find our s. So I'm using my 30, 60, 90 ratios. So that's where we're getting our s is equal to x divided by 2. Then for your altitude, you would just have your s root 3, which once again, remember our s here is x divided by 2. So we have x root 3 divided by 2. So plugging in, we've got our 1/2 of our base, which is just going to be our side length. So that's where we're getting that x from, times our height, our altitude, which is the x root 3 divided by 2. And then all they've done is they went through and simplified. Okay, so x times x is where you get the x squared from with our root 3. And then that 2 times 2 in the denominator is giving us that 4 in our denominator. So you can always use your 30, 60, 90 triangle ratios to solve for anything that you might be missing when it comes to an equilateral triangle, or if you happen to know the side length, you can just plug into this formula if you want to memorize it. All right, moving into our first problem here, we have find the height of a trapezoid that's going to have an area of 287 inches squared, and the bases are 38 and 44 inches. All right, so here we're going to have our formula for area of a trapezoid. It's just that 1/2. We've got our B1 plus B2 times our height. So I'm going to plug in everything that we currently know, which is going to be that 287 is equal to 1/2. And then our two bases are 38 plus, if I remember right, it was 44. Yes. Times our height, which is what we're looking for. Okay, so I'm going to use my algebra here to solve. I'm going to go ahead and just combine what's in my parentheses. So we'll have that 1/2, and then the 38 plus 44 is going to give me 82 times that h. Okay, taking half of that, I'm going to then we'll have 41 times h. And then when you divide, you'll get that your h is equal to 7. And so we want to include our units, which is going to be the inches. So my height here is going to be 7 inches. And that's how you would solve number 1. Now let's look at number 2. Okay, so number 2, Sage wants to place a decorative brick edging around a flower garden that is in the shape of we've got a rhombus. Okay, so let me just go ahead. We'll draw a very poor picture. I'm try my best to draw a rhombus. Mark that they're all congruent since this is a rhombus. We have that one diagonal is going to be 30 feet long. Okay, so this diagonal here is going to have a length of 30 feet. And then we are given that the area, so my area is going to be equal to 600 feet squared. How many bricks must she purchase, say, if each brick is 1 foot long? Okay, so because she wants us to be an edging around the garden that she's making, that's going to be my perimeter. Okay, here we have the area. And so in order to figure out the side lengths, I'm going to need to know what is this other diagonal length here. Because if I can find that other diagonal, remember, this is going to be perpendicular. Okay, I could use Pythagorean theorem that will help me find a side length. And once I know that one side length, I can multiply by 4 to figure out my perimeter since all of the sides are the same. So that's what we're going to do. Okay, I'm going to take my area, which is that 600, is going to be equal to my base 1. Sorry, not my base 1, my diagonal 1. So I'll have 30 times my diagonal 2, which I'm trying to find. So taking half of that 30, I'm just going to get here that we'll be dealing with 15 times my diagonal 2. And then when we divide here, we should be left with 40 for that diagonal. Okay, so we have that the full length of the diagonal is 40. I'm going to use half of that, okay, to get 20. And half of that 30 gives me 15 here. And so I'm going to use Pythagorean theorem to solve for. We'll have here that my side, I'm going to call this my x, is my side. And then we'll use the 20 and the 15 that I found. So we'll get 20 squared plus 15 squared is equal to x squared. I should get 400 plus 225 when I square everything. And then adding those two together, I should get 625 is equal to that x squared. And so when I take the square root, I'm going to get that one of my side lengths is going to be equal to 25 feet. Okay, and once again, we are going to need to find the perimeter. And so for my perimeter here, I'm going to just we'll have the 4, so you can see that a little bit better, 4, because we have 4 sides that are all congruent, times the side length of 25 to get 100 feet as my perimeter. Now, they did tell us that 1 brick is going to be equal to 1 foot long. And so here I can then just say that I'm going to have 100 brick that I need to buy. All right, so now let's move into our last problem, number 3. All right, so for number 3 here, we have find the area of an equilateral triangle with a perimeter of 60 centimeters. All right, so here my perimeter, is equal to 60 centimeters. And so since this is a triangle, I'm going to find my side by taking that 60 and dividing by 3, the 3 sides that I currently have that are congruent, to get that one side length is going to be 20, we'll have centimeters. All right, so I'm going to show you 2 ways of doing this. I'm going to show you just plugging into the formula that we had, which is my area here, remember, is equal to 1/4 of my x squared times root 3, my x being my side length. So here I would plug in to get that my area is equal to 1/4. We would have 20 squared root 3. Okay, so 20 squared should give you 400. Okay, and so I have that 1/4 of 400 root 3, which will just give me that my area is equal to 100 root 3 centimeters squared. So like I said, that would be the shortcut. If you know the formula, you can just plug in. If you don't, okay, remember you could always revert back to your ratios or even Pythagorean theorem, depending on which one you want to use. So remember, all of my sides here are equal. They are all going to be a length of 20 centimeters. And so that means here that my base would be 20 centimeters. And I would need to find my height, okay, my altitude. And so using my ratios, so this here would be my 2s. Let me do this in a different color. Then we would have my s, and then my s root 3. Just to clarify why, we would have a 60-degree angle here and a 30-degree angle up here. All right, so with my 2s being equal to that 20, that means that s is equal to 10. And therefore, my height would be equal to 10 root 3. And then we can plug into my formula for area of a triangle. We would have 1/2 my base times my height. Okay, so we would have 1/2. My base would be that 20. And then my height, like I said, would be that 10 root 3. So half of 20 is going to give me 10. 10 times 10 is going to leave me with 100 root 3. And then our centimeters squared, once again, which is the exact same answer I got before using that formula. So it's up to you, like I said, just find a way that works for you. And if you're able to easily memorize another formula, then you are more than welcome to use that one. If not, just revert back to our old material we've talked about plenty of times, which is going to be our 30, 60, 90 ratios. All right, hopefully this video helped you with understanding how to apply your trapezoid, your quadrilaterals with perpendicular diagonals, and your equilateral triangle formulas for area.